Welcome to Lesson 1 on logarithms. A logarithm is the inverse of an exponential function. Let's get started. When we write log base b of x equals y, b is the base, x is the argument, y is the exponent. This is equivalent to writing b to the y equals x. These two forms say the exact same thing. Exponential form, b to the y equals x. Logarithmic form, log base b of x equals y. You are simply rewriting the same relationship in a different format. Example 1, log to exponential. Log base 5 of 3125 equals 5. Rewrite it in exponential form. 5 to the 5th equals 3125. The base 5 stays the base. The exponent 5 becomes the power, and 3125 is the result. Example 2. Exponential to log. 8 squared equals 64. Rewrite in logarithmic form. Log base 8 of 64 equals 2. The base 8 stays the base. The result 64 becomes the argument, and the exponent 2 becomes the answer. Example 3. Evaluate. Log base 3 of 81. Set it equal to x. Log base 3 of 81 equals x. Rewrite in exponential form. 3 to the x equals 81. Rewrite 81 as 3 times 3 times 3 times 3. That equals 3 to the 4th power. Since 3 to the x power equals 3 to the 4th power, and the bases are the same, the exponents must be equal, so x equals 4. Example 4. Evaluate log base 4 of 1024. Set it equal to x. 4 to the x equals 1024. Rewrite 1024 as 4 times 4 times 4 times 4 times 4, which equals 4 to the 5th power. Since 4 to the x power equals 4 to the 5th power, and the bases are the same, the exponents must be equal, so x equals 5. Common logarithms, base 10. When we write log of x, the base is 10. We don't write the 10 because it is understood. For example, 10 to the 4th power equals 10,000. Logarithmic form, log of 10,000 equals 4. Another example, log of 1 million equals 6. Exponential form, 10 to the 6th power equals 1 million. Natural logarithms, base e. When the base is e, we write ln of x instead of log base e. The number e is approximately 2.718. For example, ln of e to the 5th equals 5, because logarithms and exponentials cancel when the bases match. Another example, e raised to the ln of 12 equals 12. Again, they undo each other. Core properties of logarithms. First, the log of 1. Log base 7 of 1 equals 0. Because 7 to the 0 power equals 1. Any non-zero number raised to the 0 power equals 1. This works for any base. Second, the log of the base. Log base 9 of 9 equals 1, because 9 to the 1st power equals 9. When the base and argument match, the answer is 1. Third, the log of a power. Log base 6 of 6 to the 10th equals 10. The base matches. The log and exponential cancel. You are left with the exponent. Fourth, the exponential and logarithm inverse relationship. 6 raised to the log base 6 of 18 equals 18. The 6 and log base 6 cancel. Whatever is inside becomes the answer. Practice 1. Evaluate. Log base 2 of 2 to the 7th times 2 to the 4th. First combine. 2 to the 7th times 2 to the 4th equals 2 to the 11th. Now apply the log. Log base 2 of 2 to the 11th equals 11. Practice 2. Evaluate. Log base 5 of 5 to the 9th divided by 5 to the 3rd. First, simplify inside the logarithm. When dividing powers with the same base, subtract the exponents. 5 to the 9th divided by 5 to the 3rd equals 5 to the 9 minus 3, which is 5 to the 6th. Now rewrite the expression. Log base 5 of 5 to the 6th. Since the base matches, the logarithm and the exponential cancel each other out. So the final answer is 6. Practice 3. Evaluate. Log base 3 of the square root of 3 to the 12th. Rewrite the square root. The square root of 3 to the 12th can be written as 3 to the 12 divided by 2. Since 12 divided by 2 equals 6, this simplifies to 3 to the 6th. Then, log base 3 of 3 to the 6th equals 6. If you enjoyed this lesson, don't forget to subscribe and give it a thumbs up. I'll see you in the next lesson.